can we do with Raspberry Pi, Arduino, 26060s. The last one was board called. It's called the RAB platform, RAB. There's a bunch of different variations. Hey folks, just a quick one from the bench. Questions as follow-ups from the last one was, what was the blue board called? It's called the RAB platform, RAB. There's a bunch of different variations, all from different manufacturers. I have one of these that's gray that's in storage. It's basically the same layout, but it gives you switch mounting positions off the bottom. Oh, yeah, it's off the bottom. I had to stop and think of where it was at. So whichever one you choose to buy, if you choose to buy one, you know, whichever you prefer. Like I said, I have kind of standardized on the RAB now because I just like the simplicity of it. It does not try to overcomplicate things. I mounted the only RasPi I had available. I was not able to get into storage this week. I did make it over there, but they're only allowing one group of people in at a time, so one unit at a time. And there were like 5 or 6 people in front of me, and I'm like, I'm not going to wait around for hours for these guys to go through. So we're going to make do with what we have right now until I can get over there. So I did go ahead and I mounted this is the Raspberry Pi 3 Model B, version 1.2. It is updated as of tonight. I updated all the operating system and did a quick flash. I mounted an Arduino Uno. We're going to be focused on the RasPi, but I thought to have a complete platform board, I might as well go ahead and do this. I had this laid out before on a piece of cutting board, old kitchen cutting board. So I'll just start with this and make it do. It's what I've always wanted to get it set up right, so we'll go ahead and do it. I just finished hooking up my power supply for my breadboard power. Anyway, so as you can see, the Raspberry Pi is actually on right now. I can switch over and show you that screen. So we are currently up and running. I verified Node-RED was working because when I updated it on my laptop, the local host did not run the Node-RED interface, so I wanted to make sure that was here. Just to have my pinouts up and handy and my Arduino pinouts diagrams. These open by default in my browser because sometimes I'm like, oh hell, what pin was that? And then I can actually look it up. And this is an interactive guide, pinout guide. And then the one for the Uno. Not interactive, but it gets the point across as to what is what. And this only covers the pinouts. So it only covers, and I missed the button. So it only covers the pinouts. So whether it's the digitals or the analog. This side is digital pinout on the Uno. This side is analog. Don't worry, the headers are marked. You can't screw it up. But just to show you, the Uno is actually up and ready. It's just going to load a single program and boom, it's done. It's ready and running. You should be able to see that. Yeah, you can see it. The LED blinking. So that's the blink program. It's the default one. But it's just to show you that that one is working. We can do a reset, have it restart, boots up, goes right back into that program. It's a continuous loop. So yeah, so I just hooked up my breadboard power supply, and I wanted to double check. My pins are marked, but sometimes the import breakouts, I don't trust them, so I always check them the first time. If you're going to buy a separate breadboard power supply, make sure to get one that has a power switch in it. Maybe it's just me, but if something goes wrong here, I want to hit a power button to turn it off. I don't want to have to snatch a barrel plug out and damage everything, or reach across and get the wall wart unplugged. So anyways, I'm ranged to 20 volts. 5 volts on the north. And 3.3 on the south. Okay. What I do, this is just me. You can set them up however you want to do it. If you're going to run a project that has multiple voltages, I will always make the north rail, so the rail away from me, 5 volts. So this is providing 5 volt power to this rail. The red line is positive, black line is negative or common. Same thing with this one. The rail closest to me is always 3.3 volts. It's just the way I do it. Do what works for you, as long as you can remember it. Anybody can sit down that knows what they're looking at, and they'll know that this is jumpered to 3.3 volts. If I can pull this down, actually I have to kind of slip and slide a little bit here. So yeah, you can see the 3.3 right there, and the 5 volt is down here. So it shows you the position of this jumper. So right now we're off. And I will pull this jumper out. So now you can see the jumper is empty. If I catch the first 2 pins, we are at 5 volts. If I catch the last 2 pins, we are at 3.3 volts. Apologies, you can't see that from my fat fingers. So if we were jumpered there, we're at 3.3 volts. If we are jumpered here, we are at 5 volts. If we are jumpered in the middle, we are at 0 volts. So that rail is turned off. Again, I always do the north rail, so the rail away from me at 5 volts, the south rail closest to me at 3.3 volts. You can run it whatever works for you. I'm not about to tell you what you can and cannot do. I'm just telling you what works for me. Wow, it's amazing how sharp that is when it's actually in focus. If you guys have watched the other videos, you know I'm having a problem with focus lately. I don't know what the hell's going on. Previous video, there was some confusion about the Arduino. When I said that all of this is extra, this is ancillary, that's not important. It's this chip that's important. And I'll stand by that point, and what I'm saying, just as an example, okay, I'm going to insert a socket head right there. And I'm going to get a chip out. Okay. So, what we're concerned with here on the Uno is really not any of this ancillary settings. In fact, if we program this chip and we get it working with all of our IOs, both our analogs and our digitals, we could take that chip out and simply insert it. I'm not going to push that one down, and simply insert it into a connector on a breadboard. So we do our programming on the Arduino board. Then we can remove the chip and install it into our project board, into our breadboard in this case, and transfer our wiring over, and we're now running fully independent on this breadboard, no longer on the Arduino platform. Because the Arduino isn't so much about the Arduino. It's more about the Atmega chipset, the Atmega chip. So we can duplicate all of these functions here on a breadboard, or we can pre-program it in this environment as an EEPROM, for those of you who've been around for a long time. So we can take that EEPROM, transfer it over to our own program, or transfer it over to our own custom-made PCB, printed circuit board, like we talked about in the previous. So don't overthink about it. Don't overthink it. This is the I/O. This is the chip. This is what's doing the work on the Arduino. Again, back to the Raspberry Pi. This is a full computer. It does have input-output. It does have serial bus. It does have network. It does have, as I reach around, where's my little pointer? It does have audio. It does have a camera input. It does have a display input. It has mass storage, the micro SD. It can have mass storage through USB. I feel like I'm hashing that one talk over again, but I think it's, you know, it's something worth repeating, because I got asked a few follow-up questions after that video, and it made me wonder, did I not explain it right? Or and then there was the other question about the 8266. Can you breadboard the 8266 that I had talked about? So that question about the 8266s. I'm just looking. I never thought about breadboarding them. In my IoT box, I actually have a breadboard of sorts that is specifically designed for the 8266 pinout. This is a Node MCU, for anybody that's looking. So yes, you could insert this down into a breadboard, make your pin connections, although you're pretty tight on real estate, but yeah, that does work. Second row, yeah. It does work pin for pin. So you would actually make your, just show you. So if we need to go from pin D1, you know, we could go from pin D1 to wherever we need to go. If we need to come down to the rail, so this is our 5-volt positive, 5-volt negative, or we can run the wire around, or around this way to plug in over here somewhere to connect to, you know what I'm saying? Again, I'm trying to oversimplify this, but so yeah, you can breadboard those. The other question I had was on the serial connector. So yeah, I was talking about prototyping boards or custom PCBs, where I was saying, you know, for serial I/O, as far as programming. So the comparison I can use, again, is with the 8266. You can see that it has a micro USB connector right here on the end of the board. Well, we'll say you've done a custom circuit board, so this green part, for somebody, for a project that you've built for somebody, and you don't want them to have access to it to change the actual code of the program. Well, there's a micro USB there, so what are you going to do? You could, again, go back, and we'll just say you've done a program, you've moved the Atmega onto your own custom circuit board. You can run channels over to an empty header. Well, there's 2 test points down here on the RasPi. This is a good example. So just take this female pin header. If you leave a female pin header on your circuit board, they don't need to know what it's for. And that's where the little boards like this come in handy. This is a serial chipset for USB. So just simply, no power on there. I'm just, as an example, I can come in and plug in that board, this board, into my finished project. This allows me to attach a USB cable, have serial communications with my chipset. So I can jump in, modify the program, flash firmware, whatever I need to do on this. When I'm done, I power down the project, I remove my serial adapter, and out I go. So now my program is safe on there and they can't access it. It's a silly way to use it, but it's the way you see a lot of these things used. I actually saw them being used on HVAC units. Of course, the guys didn't know what they had in their hand, the service techs, but because this was encased in a header, so they just plugged it in and it was hooked up to their laptop. They didn't know what this did, but it allowed them to access the firmware. And speaking of time to go, all right, guys, I'll get this one up to you. Again, it's just me rambling, really, as I'm setting this stuff up and thinking through where I want to go with this. So, comments below, like, comment, and subscribe. All right, guys, more soon. Be well. Countdown activated. 5, 4, 3, 2, 1.